Bonjour à tous. Donc, Donatien.
Hello, everybody. Donatien de Lesquin. I work for FH Roads. I work for the design and innovation sector, and I'm here to talk to you about the deflection of wearing courses. I'm going to be going into detail on the work that we've done, the calculators, the behavior, and the production of new road pavement courses, wearing courses, and everything we can say in this context. Initially speaking, I'm going to be talking to you about the ACT guide. Then I'll go into detail on the objectives of our work, the methodology, a few results, and I will draw my conclusion. So first of all, the ACT guide. This was published in 2003. It was designed for project owners to enable them to choose the best wearing course so that they could then perform the maintenance work in the countryside and in peri-urban areas. The idea was to provide them with technical documents for each of the different road techniques so that they would then have access to all of the details on the advantages and the disadvantages of the different wearing courses. So what you can see on the photo is that for the different road surface courses, the guide recommends, depending on the volume of traffic, you need to have a deflection threshold that you do not exceed in order to be able to apply everything that's in the guidebook. So we showed an interest in the deflection values. We wondered where the deflection values come from. So we did a bit of research work, and we came up with deflection values as a function of the traffic in various guides. So when we dug a bit deeper, we were able to contact the ACSE guide, and they confirmed to us that the choice of defining maximum deflection thresholds, it was based on an empirical study following on from feedback given by experts who worked on different work sites in France in the network, who simply gave their impression, their opinion on the levels of deflection not to be exceeded. So the issue of this kind of empirical approach is that it doesn't give us the opportunity to propose alternative solutions or to come up with innovative solutions in relation to what already exists. And so this is why we decided to take a closer look at how we could come up with a rational approach as to the wearing course that would be chosen, taking into account the deflection behavior. So we looked at one thing. We worked out, can we work out what the maximum level of fatigue can be, and can we create a degree of consistency between that and the traffic and the potential wear in order to try and work out the optimized level of fatigue and the optimized type of wearing course. So these were basically the objectives that we set within the scope of the action. The big problem with the ACT guide is that it provides very little information on the different types of wearing courses. They talk about maintenance work, for example, where you add a new wearing course on top of the original road pavement surface, but we don't really know what type of surface structure is being imposed. We don't know the extent to which damage has occurred. So we had to come up with a certain number of hypotheses in order to be able to look at as many different deflection possibilities as possible. And we needed to see what the wear and tear was going to be on all the different base courses potentially. So here you have the whole list of hypotheses that we came up with using the CERAMA guides for reinforcing road pavements, everything that they recommend. Next, when it comes to the modeling process, we relied on the Alizé software. Why did we rely on this? Well, we know that Alizé, when it comes to road pavement contact, as has been said, it's not necessarily very reliable when it comes to the contact point between the tyre and the road surface. However, everybody uses Alizé. So if we have values that have been calculated by Alizé and that we can then link back to deflection, we thought that it would suit everybody, let's say, or would at least be accepted. So thanks to Alizé and all of the road surface structures, the different base courses, the different surface courses, we were able to perform a massive number of calculations. And for each calculation, we had the values above and below the new wearing course for which we'd calculated the deflection values and also the curve ratio. And then we were able to analyze all of this data thanks to an Excel file that enables us to sort through the different parameters that we wanted to observe. So here you've got just some of the results that we obtained. I'm not going to necessarily go into detail on all of the results because there's so much we could say. However, what we can see is you don't get the same behaviors depending on the type of wearing course that we've examined. You can have the impact of certain parameters. On the table here, for example, you have the impact of the former wearing course. It all depends on what's being used as a binder. What we can also see is that we have certain types of wear that are considerable when we look at epsilon 6 and what's used for the design. This is very important. We imagine that we ought to pay a lot more attention to the stress, for example, the potential stress when we're choosing the wearing course. Unfortunately, to give some form of matching between our calculations and the ACT guide, it's very difficult to match the two because at the end of the day, the wear depends on the stress depends on many different factors. We thought that we'd have varying degrees depending on the deflection, whereas in fact, we got rake-like results, as you can see on the screen, so it was very complicated to analyze. We realized also that when we talked about wear in relation to the bends and not in relation to deflection, the results varied, so it made it very difficult to draw conclusions. And the issue is, if we look at stress in relation to the bends, we're never in line with the ACT guide because they only focus on deflection and they never talk about the curve radius. So just to conclude on the work that we performed in relation to the ACT guide, we were able to see that the ACT guide is based on an empirical approach, and very much so. We attempted to propose a method in order to streamline and rationalize everything so that we could then potentially provide new solutions on what wearing course to use. We used the Elysée solution to look at the different wearing courses in the hope that we could use it for designs of the future. However, it would seem that at the end of the day, deflection is not necessarily the best parameter for establishing the most appropriate wearing course. We thought it was in fact better to look at the bend ratio. In the report that I recommend and is in the books provided by DVDC, we suggest an approach based on 4 points, tests that haven't yet been carried out. We're still talking about them, and we're thinking about the most appropriate method to apply, and it will involve the curve radius. So it's very much open to discussion for the moment. So thank you very much. I have a little bit of time left just to show you a few pictures. Thank you for listening. And if you have any questions, please feel free to contact me during the course of the day or by email further down the line. Thank you.